So today we're going to be moving on, into the next subtopic, which is transformer. Whenever we come to this subtopic, sure akan ada orang yang salah konsep lah. Okay, and the biggest salah concept is apa yang dia orang tengok sejak dari kecil lagi lah. Okay, which is this, and they think that this is the transformer. Padahal this is a cartoon that was done when I was very young lah. Okay, this cartoon ni wujud sejak saya masih budak kecil lagi tu, and then it became a movie, and everybody thinks that kalau kita cakap pasal transformers kan, kita adalah bercakap tentang benda ini. Okay, padahal a transformer is a totally different thing that has nothing to do with those transforming robots. Okay, so benda yang transform dipanggil sebagai transformer. Okay, but actually in physics, okay, transformer is a very big application of electromagnetic induction, which we were learning in the previous subtopic lah. Okay, so we know that from the previous subtopic, when electromagnetic induction happens, okay, we produce current. Okay, and when we produce current, okay, the idea is to generate the current. Nama pun generator. Apa yang kita sedang menjana? What are we generating? We are generating electricity. We are generating current. Okay, so in all of this, there is a function for this thing called transformer, because it is an application of the electromagnetic induction, which we learned in the previous subtopic. Okay, so one of the biggest, look at our house, when we have a switchboard like this, I think it's called a switchboard. Okay, so when we have a switchboard like this, usually the potential difference or the voltage that is given to us in the power supply is about 240 volts. Okay, you will see this over here. Okay, but our mobile phone, when we charge our phone, they only operate on the potential difference of 6 volts. Okay, so the question is, how does this 240 volts, okay, how is it converted? How is it transformed into 6 volts? Okay, by use of a transformer. Because imagine what will happen if the mobile phone, you connect directly to a 240 volt supply. Okay, you provide 240 volts to the mobile phone, you're going to get the exploded mobile phone. Okay, so how is it possible to adjust the potential difference? How do you transform the 240 volts to become 6 volts? Okay, and this one we use a transformer. Okay, so when we open a charger, we will actually see this component in there. Okay, this is a handphone charger that runs on a low voltage of 6 volts, which can be connected when you connect it to a 240 volt through a transformer. Okay, so what does a transformer do to the voltage supplied to it? Okay, so this is actually a transformer that is inside all your chargers. Okay, inside your charger inside your USB depending on which is this one. But standard chargers, that's why the chargers are big, Okay, because there is a need for a transformer in there. And that's why also, and we will see why later, okay, why when you charge something for a very long time. Let's say if you're watching this class on a laptop now, lama-lama kamu charge kamu punya laptop bahkan, okay, you're going to find that the charger is going to feel very hot. Okay, why? Okay, these are questions that we will answer in this subtopic. Okay, so this is a photograph, okay, of a step-up transformer. Okay, for example, in this, so there are two types of transformers, which we will come to in a while. A step-up transformer that you can find in a microwave oven, and a step-down transformer, okay, which we will usually find in a mobile phone charger. Okay, so the question is this: how does a transformer change an input voltage to an output voltage with a different value? This is the big question we want to answer today. How do we use electromagnetic induction to change the input voltage, which is 240 volts? Okay, you put your finger inside the plug, which I don't suggest you do. Okay, that's why we tell small children, don't poke your finger into the lubang, the plug. Okay, because it's 240 volts, being supplied there and then. But why is it that when we chuchok our charger, it can safely charge our phone without our phone exploding? Padahal the phone charger, in order to charge the phone, the battery of the phone, you only need about 6 volts. 6 volts of potential difference, okay, in order to charge it. So how does that 240 become 6 volts? Okay, and that's where the transformer comes in. So a transformer is a device that increases or decreases an alternating output voltage. That means benda yang masuk, our standard over here in Malaysia, our voltage yang masuk is usually about 240 volts. Our standard input voltage lah, okay, is 240 volts. But it either increases or decreases an alternating output voltage. That means the output can be higher than 240. It can be maybe 1000 volts, okay, or it can be even as small as 6 volts, okay. But it is working based on the principle of electromagnetic induction. This is a very important thing, okay, and this is why again this is why this is my favorite chapter, because without the concept of electromagnetic induction, right, there will be no possibility of us doing this online class. Wow, kalau kau mau salahkan online, kalau kau mau salahkan diorang salahkan lah, you can blame Faraday and Lenz's law. You can blame Faraday and Lenz and all the people that discovered electromagnetic induction for the reason why we're having online class today. Okay, because without them, we won't be able to do online class. Okay, you will probably still be listening to the teacher teaching over the radio. Okay, not sure whether you've seen the meme now. So let's take a look at the components, okay, inside a simple transformer. Okay, so you first have the primer voltage or the primary voltage, depending on some books called primary voltage, some books called primer voltage, the same thing, but it is the input voltage. Okay, and I want you to make a star over here, okay, to write down that it must be alternating current. Okay, why? In a little while I'll explain. The transformer can only work, dia hanya boleh berfungsi sekiranya dia adalah arus ulang alik. It cannot work on an arus terus. Okay, you can try if you want, but it will definitely not work. Okay, second part of the transformer is the secondary voltage, which we will see here, okay, otherwise known as the output voltage. Okay, usually we connect it to the electrical bulb, or motor, or whatever lah. Okay, you can put your handphone over here also, because it is the one that is receiving the amount of voltage needed. Okay, coil, sorry, the third one is the primary, sorry, spelling error, C-O-I-L, primary coil, okay, which is here, given the symbol of NP. Notice all the P and S. VP is primary voltage, VS is secondary voltage, NP is primary coil, which is connected to the input voltage, this one. Okay, and therefore the secondary coil NS will be the coil that is, this is the coil, okay, which is connected to the output voltage. Okay, and the most important component in the simple transformer, okay, is the soft iron core. Okay, so this metal, this thing over here, okay, is a soft iron core that serves as a link between the magnetic field lines between the two coils. Okay, and in a while I will explain. So this is how it will look like this is how it will look like in our lab. Okay, so this is the soft iron core over here. Okay, ignore the animation lah. Okay, so this is the soft iron core over here. This will be the primary coil, and this will be the secondary coil. Okay, primary coil over here is the secondary coil. So this is the input voltage, and then it will go out to the output. Just to show you, we use an ammeter lah. In this case, we are using ammeter to show lah. But this is how the soft iron core will look like. Okay, but again, as I said, this is a lab version. Okay, of course, the real transformers are depending on where you want. If you want to increase the voltage, the real transformers are huge. Okay, are these huge structures. Okay, but in our phones, it's these very, very tiny structures, which you can actually see the soft iron core very tiny inside. Okay, now the symbol for a transformer, okay, is this thing over here. Okay, this is a symbol for the transformer. So these two lines over here represent the soft iron core, okay, which is important to draw. And then you have the primary coil, okay, and the secondary coil. Over here, if you notice, the primary coil, okay, has more turns. The secondary coil has less turns. Okay, 1, 2, 3, 4, 5. Here only got 5 turns. Here got 1, 2, 3, 4, 5, 6, 7, 8. Here got 8 turns. Okay, in a while, I will explain to you what is the significance of these turns. But the primary circuit is always connected to the power supply. The secondary circuit is always connected to the electrical device that you want to provide that voltage with. Okay, so in short, this is how the transformer will look like. Okay, primary coil on one side and 2 lines for the soft iron core, and then secondary coil on the right side. Okay, today is kind of like very lecture style, so there's really not much talking on your end, I think. But if there's anything that you want to ask, feel free to unmute yourself and ask. Okay, now let's talk about the operating principle of a transformer. So this is how the transformer operates. Very, very important part, this one. Okay, you might want to start this, especially number 2. So state the physics concept which explains how transformer works. The physics concept is electromagnetic induction, which is why I spent a very, very crazily amount of time. Okay, it's too long. Usually people will finish electromagnetic induction in one class. Satu class sebenarnya boleh habis ini. Okay, but I spent 4 classes teaching about electromagnetic induction because I feel it's so important. We need to understand how electromagnetic induction works in order for us to understand how the transformer works. Okay, and I hope that by now you guys, all of you have an idea of how electromagnetic induction happens. Okay, it happens, you produce an induced current by cutting the magnetic flux. Okay, and we use that concept okay, in the application of a transformer. Now, one of the things that I said just now is that the input voltage must be from an alternating current source, cannot be direct current. Okay, so remember in the direct current generator, this is this one. So the current only flows in one direction. But in an alternating current, okay, the current will flow in different directions. Okay, it will flow this way to this way, and then after that, the next moment, it will flow this way to this way. Okay, so arah arus sentiasa berubah. So why is this very important? Okay, number 1, because alternating current has varying magnitude and direction. Direct current only has varying magnitude. Okay, direct current magnitude-nya berubah-ubah, tetapi alternating current dia bukan saja dia punya magnitude berubah, dia punya direction also berubah-ubah. Okay, what does this varying magnitude means? Because if you notice, getting bigger, getting smaller, getting bigger, getting smaller, getting bigger, getting smaller, getting bigger, getting smaller, but in the same direction. Okay, that's direct current. Alternating current is getting bigger, getting smaller, getting bigger, but the other direction, getting smaller, getting bigger, getting smaller, getting bigger in the other direction, but getting smaller in the other direction. Okay, so it's not just getting bigger and getting smaller, it is getting bigger and getting smaller and changing directions at the same time. Okay, that's why it is very important that we use alternating current, because the magnetic field produces a varying magnitude and direction. So the change in the magnetic field will produce an induced current. Okay, so bila arus mengalir di sini, disebabkan arus, because the current has a changing magnitude and direction, so the magnetic field yang dia hasilkan will also have a changing magnitude and direction. Dia pun akan berubah. Sekejap sini utara, sekejap sini selatan. The next minute, sekejap sini yang utara, sekejap sini yang selatan. Dan berubah-ubah dia punya kekuatan. Okay, berubah-ubah dia punya kekuatan. So because of that, sekejap sini utara, sekejap sini selatan. Sekejap sini utara, sekejap sini selatan. Lepas tu tukar lagi. Sekejap sini yang utara, sekejap sini yang selatan. Okay, what is going to happen is this magnetic field, okay, dia akan terpotong di sini juga. So that means The magnetic field yang sekejap sini utara, sekejap sini selatan, sekejap sini utara, sekejap sini selatan kan, dia akan berubah-ubah. Dan in the secondary coil, what is going to happen is there is going to be a change in magnetic field. Okay, actually if you think about it, the secondary coil kan is just duduk dan tidak buat apa-apa langsung tau, dia hanya merasakan perubahan saja. Okay, if you think about it, sebenarnya yang bekerja is the current on this side. The current in the primary coil is the one that is working, change direction, change direction, change direction, change direction. Okay, and then the secondary coil is like, oh, kau change direction kah? Oh, kau change direction balik kah? Oh, kau change direction kah? Oh, kau change direction balik kah? Begitu. But because the secondary coil, okay, is experiencing the change in the magnetic field. Okay, 1 minute this way, 1 minute the other way. So it is going to produce an induced current based on electromagnetic induction. Remember, electromagnetic induction is the production of current. And yesterday, Iqbal was very excellent at this. He mentioned this very correctly. Production of current because of the change of magnetic field or the cutting of the magnetic flux. Okay, so when there's a change in magnetic field, the secondary coil, there will be an induced current. Okay, and how does the change of magnetic happen? Because this guy is changing. Okay, alternating current, sekejap sini, sekejap situ, sekejap sini, sekejap situ. Okay, so this is the explanation of this. So how to change the magnetic field, direction and magnitude. This is not in your module, okay, but it's just for us to recap what we have learned so far. Now, when a direct current, okay, battery, like a battery is used, there is a magnetic field. But the utara dan selatan sentiasa di tempat yang sama because the direction of the current flow is always the same. This is something you learned in Form 3. Okay, but when you use an alternating current, as I said just now, okay, dia sekejap sini utara, sekejap sini selatan, sekejap sini selatan, sekejap sini utara, because the current changes direction. Okay, that's why when you produce a magnetic field, the direction and the magnitude always changes as well. Okay, and we saw this in the first subtopic and the second subtopic. Okay, we find that this is again, as I said, an example of the graph for an alternating current. Okay, dia akan besar kecil. Okay, and we find that the direction of the magnetic field always changes. Okay, because sekejap sini, sekejap sini, sekejap sini, sekejap sini. Okay, very important thing, alternating current. And that's why a transformer can only work with the alternating current. Sebab alternating current saja yang boleh menghasilkan medan magnet yang berubah-ubah. Alternating current is the only current that can produce a changing magnetic field. Okay, okay, let's say if I let's say saya mengada-ngada lah, okay. Let's say I put direct current over here lah. Okay, let's say I put direct current over here. Tapi saya mau juga transformer. Okay, then what should I modify in this section in order to make sure that I can get an induced current? What do you think? Anybody want to throw any ideas to me? Let's say I provide direct current lah. Saya mengada-ngada lah. Saya mau juga battery saja di sini. Okay, because I got nothing better to do kan, saya letak battery di sini. But I want to make sure that this transformer is functioning. So what do you think I should do to this side in order to make sure that I can get this output voltage over here? How would you move the coil? How would you move the coil, Mordecai? Yeah, you probably have to use an external force. Okay, you probably have to have somebody pegang itu coil and then move it like this, so that so that the magnetic field from the direct current, okay, will always cut the coil, which is kind of bodoh, right? Don't you think so? Isn't it better to use alternating current and let the current do the work for you rather than saya bergegas juga, saya mau juga direct current sebab saya suka huruf D, I don't like the letter A, okay, because D is for Damir and A is for Adam, I don't like A, begitu. Okay, sorry, totally no relevance lah. But isn't it I mean, it's illogical. You can use direct current, but you will have to continuously move the coil. Okay, try just hold your calculator and try doing this for 1 hour. See if your hand get penat or not. Okay, sure your hand get penat one. Okay, that's why alternating current is so important, because alternating current helps you so that you don't have to move the coil. Let the current change the magnetic field for you. Okay, banyak pula saya membebelkan. Okay, let's go to this. Okay, so how is current induced in a secondary coil? Okay, the working principle of a transformer. Number one, when an AC voltage Vp is applied to the primary coil of the transformer, and alternating current flows through the coil. Okay, so this red color over here, okay, alternating current flows through the coil. The soft iron core will be magnetized. Sebab this, when current flows over here, there will be a magnet, and then this whole soft iron core, because it is a metal, dia sendiri akan menjadi magnet. Sebab magnet bersentuh dengan besi, bahkan dia akan jadi magnet sendirilah. So it will be magnetized. And the alternating current has a varying magnitude and direction. So there is changes in magnetic direction of the magnetic field. That means this blue color, this magnetic field, dia akan sentiasa berubah arah dan kekuatan. Changing direction and changing magnitude. So the soft iron core is the linkage between the primary coil and the secondary coil. All this is in your module kan. It's just that all these words are left empty. Okay, and so because the red color wire over here changing magnetic field, the soft iron core is touching the red color wire, so it also will have a changing magnetic field. And since this soft iron core is also touching this, it's like, when you play kejar-kejar last time kan, there's all this current bahkan. I don't know, do you ever play those games when you were like a small kid lah? Like kalau kamu current kan, terus boleh tersentuh tu orang di sana tu. Okay, never mind. Okay, it provides a varying magnitude and direction of the magnetic field in the secondary coil. Okay, and this causes a changing magnetic field that passes through the secondary coil, and so an induced current and AC secondary voltage is produced across the secondary coil. Okay, that's why the laminated soft iron core is very important. Dia menghubungkan the changing magnetic field. Okay, dia sendiri menjadi magnet, so dia bersentuhan dengan magnet. Okay, this is a magnet disebabkan oleh arus mengalir lah. Okay, and then because dia sendiri menjadi magnet, dia akan menjadikan wire ini yang langsung tidak buat apa-apa. Okay, it also becomes a magnet on its own. Okay, so this is a 1, 2, 3, 4, 5, 6, 7 point explanation. Okay, 7-point explanation about how the current is induced in the secondary circuit. Okay, very, 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 very important. Okay, let me give you 1 minute to copy down the words that you need to copy. Okay, let's continue. So, primary circuit, this is a short form of the whole thing lah. AC power supply produces alternating current produces a magnetic field from the primary coil, and then after that, changing magnetic field, and then, okay, this is the formula that we are going to use in a little while. Okay, Vs over Vp equals to Ns over Np. Okay, but the most important thing is Vs refers to the voltage on the secondary coil, Vp is the voltage on the primary coil. Voltage, okay, or potential difference, not current. Okay, not current. Although, okay, what is induced? Okay, what is induced is actually the alternating voltage. Okay, please take a look at this video. Wow, video lagi.
The working principle of transformer. Actually, transformer is a machine, but it does not have any moving part. That is why a transformer is referred to as a static machine. A transformer has three main parts: two windings and a metallic core on which the windings are wound. Windings are in the form of coil made of a good conductor of current. The windings of a transformer play a main role in the machine. The winding coils behave as an inductor. When an alternating current is allowed to flow through any of the windings, there will be an alternating flux produced surrounding the winding. The magnitude of this flux is proportional to the magnitude of the current flowing through the winding. The direction of the flux is according to the direction of current. The direction of the current in the winding can be found out by applying right-hand grip rule. This rule states that when we grip our right hand with stretching the thumb along the axis of coil or winding and other forefingers along the direction of current in the coil, then the thumb indicates the direction of produced flux inside the coil along the axis. This flux becomes maximum in magnitude when current reaches its maxima for 1/2 cycle of the alternating current wave. The flux becomes zero when current in the coil crosses zero axis. Again, for next half cycle, the flux becomes maximum but in opposite direction when current reaches to its reverse maxima. In this way, alternating current produces continually varying flux surrounding the winding. The flux lines link the winding itself, and the flux is varying, so there will be self-induced EMF across the winding. This phenomenon is due to Faraday's laws of electromagnetic induction. This induced EMF or voltage, whatever you say, is same in magnitude and opposite in polarity of supply voltage. Supplied alternating voltage causes alternating current in the winding, which produces continually varying flux inside and outside the winding. This continually varying flux produces induced EMF across the winding. So we can say that the supply voltage is caused. An induced voltage in the winding is an effect of this cause. Hence, according to Lenz's law, this induced voltage will be in opposite polarity of supply voltage. Since, according to Lenz's law, effect always opposes cause. This self-induced voltage across the winding does not depend upon the number of turns in the winding, but depends on the supply voltage. But the voltage induced per turn depends on the number of turns in the winding. This is nothing but induced EMF divided by the number of turns in the winding. We have said that there is another winding in the most basic transformer, but till now we have not discussed it. Now we are coming to second winding in the transformer. Supposing one separate winding is brought nearer to the first winding, then this second winding gets kinked with a portion of varying flux of first winding. Due to this varying flux linkage, there will also be an induced EMF across it. This induced EMF would be quite small, as because the flux linkages is small. Hence, rate of change of flux linkage is also small, and according to Faraday's laws, induced EMF across a coil is directly proportional to the rate of change of flux linkage. If now we connect a closed circuit across the second winding, we will get a very tiny current through the circuit, provided the second winding is placed much nearer to the first. So we have seen that some portion of the input power is transformed to output through the second winding. This is because some portion of generated flux of first winding is linked with second. Now, if we want to transform maximum electric power from first winding to second winding, we have to link maximum flux of first winding to second winding. This is done by placing a low reluctant magnetic core in between these windings. Steel is a well-known low reluctant magnetic material, so we normally use steel for making low reluctant magnetic core in the transformer. As soon as we place a steel core in between these windings, nearly the entire flux which was surrounding the first winding will be concentrated inside the core and link with the second winding. As nearly the same flux links with second winding, now the rate of change of flux with respect to time is equal in both windings. Since, as per Faraday's laws of electromagnetic induction, induced EMF across a conductor is directly proportional to the rate of change of flux linkage. The voltage induced per turn in both windings will be the same. We have already explained that voltage induced across the first winding is the same as the supply voltage. Actually, here we consider that there is no voltage drop between supply terminals and the first winding. This is an ideal case. For theoretical purposes, we will consider that condition. As this first winding is connected with supply, it is referred to as primary winding. Now, if this primary winding has N1 number of turns and supply voltage or induced voltage across primary winding is V1, then voltage per turn in the primary winding is V1 by N1. So far, we have understood that exactly this V1 by N1 voltage will appear across each turn of second winding. So if this second winding has N2 number of turns, then total voltage across the second winding is N2 into V1 by N1, and let us say this is V2. If now any closed circuit is connected across the second winding, it will provide voltage V2 across the circuit, and due to the voltage there will be current flowing through the circuit. Normally in a transformer, this second winding is connected with load circuit. This winding is referred to as secondary winding. If the number of turns of secondary winding is not equal to that of primary winding, that is, if N2 is not equal to N1, then secondary voltage of the transformer is different from primary voltage. Now, if N2 is greater than N1, the secondary voltage will be more than primary voltage. On the other hand, if N2 is less than N1, the secondary voltage is less than the primary voltage. The former is called a step-up transformer, and the latter is called a step-down transformer. This is the most basic theory of a transformer. Hope you understand. Thank you.
I like the way that at the end kan dia cakap, hope you understand. Okay, there are a lot of things that I have mentioned at the beginning, but actually she also mentioned it lah. Okay, but there are a couple of words. Ada beberapa perkataan yang memang a little bit bukan off, tapi you know she is explaining right from the beginning from electromagnetic induction, which is what you're seeing over here lah. Okay, so when we provide an AC current, okay, it's going to produce a changing magnetic field. And so if the idea is, and so of course you talk about Faraday's laws of electromagnetic induction and effect opposes current, blah, blah, blah. All this we know from electromagnetic induction. But the idea is this: if you bring another coil near to the coil that already has voltage running through it, kan, dia sendiri akan mengalami perubahan medan magnet. Because do you see these dotted lines over here? These are all the magnetic fields. And if the magnetic fields are always changing, that means this magnetic field is going to cut here and cut back and cut here and cut back. And
First winding.
Sorry.
And this second winding.
And so it's going to produce an induced current, okay, flowing into the secondary coil. Okay, but the problem with this situation is that some of the magnetic field akan terbebas, but they will run away, and then it's not efficient lah. Okay, so a good way to make sure that all the magnetic fields, okay, are concentrated is by connecting them to a steel core. In our case, we call it a soft iron core. So this is not so effective because there is going to be some magnetic field yang akan kehilangan lah, dia akan tidak akan terkena kepada this one bah. Okay, so the way what we do is we connect them okay, with the steel iron core so that when the magnetic field is produced over here, all the magnetic field is concentrated in the steel core or in the soft iron core. Dia tidak akan terbebas macam keadaan ini. Okay, so that's the function of the steel core, is to make sure that all the magnetic fields is concentrated inside, okay, and so that all the magnetic fields yang terhasil di sini akan dialami oleh the secondary coil. And the principle is the same. Okay, when there is a magnetic field and it is a changing magnetic field, okay, it's experienced by a coil, it is going to produce an induced current. This is not magic. Okay, it is not suddenly other current. It is not that. It is just science. Okay, the changing magnetic field in a conductor, a conductor in a changing magnetic field will experience an induced current. Okay, and then after that, she goes on to give all this. This is actually a little bit higher level, okay, d omega dt. No, this is not omega. This is, it's omega. Yeah, okay, sorry. And so the important thing is this, okay, if your number of turns over here, okay, the word that she uses is called windings. Winding is lilitan, but in our syllabus, we call it the number of turns. So if the number of turns, okay, in the primary coil is...
The latter is called...
If the number of turns in the primary coil is bigger than the number of turns in the secondary coil, we call this a step down transformer. Okay, because what is going to happen is here the voltage is going to be less. This is very easy to remember. Kalau kamu punya lilitan sikit kan, maksudnya voltan kamu akan sikit. Kalau kamu punya lilitan banyak, kamu punya voltan akan banyak. Jadi kalau if the primary coil is more than the secondary coil, then you know, okay, that the secondary coil is going to have less voltage than the primary coil. But if your primary coil has less turns than the secondary coil, let's say this N2 dia sampai ke langit lah dia punya coil, then you know that the voltage that is supplied here is going to be much bigger than the voltage that you originally supplied. And we call this a step up transformer. So the words step up and step down okay, actually indicate to us kita mau menaikkan voltan atau kita mau menurunkan voltan. Menaikkan voltan macam contoh yang I gave just now, the microwave oven. Okay, you need a much higher voltage than 240 volts. So there is a step-up transformer. Okay, but in your handphone charger, you don't want 240 volts of electricity flowing through your handphone. You want only 6 volts. So you need to step down the voltage from 240 to 6. So you're going to see that inside the transformer there, the incoming one, the number of turns is much more than the outgoing one, the one that is actually connected to your phone. Okay, because we want to step down the transformer. It's the easiest principle to remember. Okay, banyak lilitan, banyak voltan. Because banyak lilitan, okay, the more turns means more cutting of magnetic flux. More cutting of magnetic flux means bigger induced current. Okay, very easy principle to remember. So let's finish with this. Let's finish this activity 2. Okay, why does the transformer not work with a DC power supply? Because a current is induced in the secondary coil only when there is a change in magnetic field. Okay, if there is no change in magnetic field, okay, then there cannot be an induced current. So a DC supply gives a direct current, okay, in the primary circuit, which magnitude and direction actually does not change. Actually, the magnitude changes but if it is a DC, generator, sorry, so the magnitude doesn't change because the voltage you supply is steady saja, okay, and so because of that, there is no change in magnetic field in the secondary coil. Therefore, no induced EMF and current produced. Okay, so let's state the relationship between the number of turns in the coils with the voltage in the transformer. Okay, can anybody tell me this? What is the relationship between the number of turns in the coils and voltage in transformer? Sorry, this class doesn't work with anybody, right? I have to call the name. Come on lah, don't make me call the name lah. Just somebody lah.
Directly proportional.
Okay, it's directly proportional. Okay, the bigger the number of turns, the bigger the voltage. Okay, it's easiest principle to understand. And this is something that we learned in the second subtopic because this is Faraday's Law. Okay, of course I know Faraday's Law dia punya perkataan sebenar, the actual definition is very long and very complicated. Okay, and it's like, okay. The induced current is directly proportional to the rate of the cutting of magnetic flux, blah, 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 blah. But basically, the bigger the number of turns, the bigger the voltage. Okay, the bigger the induced current. The bigger the number of turns, the stronger the magnetic field, okay, you will have a bigger induced current. This is Faraday's law in action. Okay, and it is the law that we use, okay, to talk about transformer. I think this was yesterday. Whose question was this? This was Wilson's question, right? He is the one that correctly identified Faraday's law. Okay, so the equation to relate VP, VS, NP, and S in the article, but in the video just now, it is the same thing, except that they call V1 and V2 and N1 and N2, right? Okay, we use P and S to differentiate between primary and secondary. Primary coil is where the voltage is supplied. Secondary coil is where you supply the voltage. Okay, sorry, where you listen lah. So primary coil is contohnya kamu punya plug lah. Okay, and secondary coil, the voltage of the secondary coil will be, let's say, your phone lah, your microwave oven lah, your TV lah, all those things. Okay, do you remember sorry, I'm going to take a little bit more time. Do you remember in the previous lesson, in the previous chapter, I asked you to look at your power ratings. So all of you have different electrical appliances with different power ratings. For example, sorry, I don't remember. Let's say, okay, let's say my fan, okay, I can't remember. My fan, I think the power rating is only about 240 volts. Okay, 240 volts and 60 watts. I think so. Okay, so this is the power rating. So as I said just now, why is it that we always have this standard thing? Most of our electrical appliances we use 240 volts. Okay, because that is the voltage that is supplied into our socket. Okay, itu adalah voltage that is supplied into the socket. But does it mean that when I connect my fan to 240 volts, that actually 240 volts is running through the fan? No, it is not. Okay, it is not 240 volts running through the fan. Somewhere inside the fan, somewhere inside your electrical appliance, there is a transformer that is changing the 240 volts, okay, to another voltage, okay, so that it can function properly. Okay, so transformer is a very, 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 very important application in our lives today. Without the transformer, you cannot even use your phone. You can't even charge your phone. Okay, you have to find ways to charge your phone. Sambung kepada bateri 9 volt. Begitu. Okay, and buy loads and loads of batteries. Transformer is so important. Okay, it is so important to us. We need to know how it works. Let's compare. Okay, you know what? Let's stop here for today. Okay, we will talk about the step-up transformer and step-down transformer in the next class. But for today, I just want you to make sure that you know this formula. Okay, I want you to know how the transformer, the working principle of the transformer, how it works. Okay, number two, you need to be able to explain how. It's not enough just to know, but you need to be able to explain. It is a 7-point explanation. Sorry, this one. Okay, it is a 7-point explanation how the current is induced in the secondary circuit. Number three, you need to be able to make sure that you tell me why we use AC and not use DC. Okay, so there is no homework for today because as I said just now, as I said yesterday, your actual homework is the flip grid yang saya suruh kamu buat DC generator, AC generator. I still want you to do that first. Okay, but at the same time, okay, if you can, please read through these notes again and really aim to understand how a transformer works. Okay, because once again, the same thing like I said before, when you understand how a transformer works, okay, then you will be able to see, okay, you will be able to see how important it is in our daily life. Okay, we use transformer every day without even thinking it. Okay, and it is definitely the transformer that is more useful than this transformer. Okay, this is like the totally totally no use. Okay, no use in everyday life. It's just except to entertain us. Okay, so so yeah, so please come on guys, be physics students lah. Don't be don't be kids. Okay, yang transformer is bumblebee and bumblebee is transformer. And then when you show the real transformer, they're like, no lah, kamu menipu ini bukan transformer. Transformer adalah bumblebee. I will see you in our next class on next Tuesday. Okay, have a good weekend everyone. Bye.